All right. Hi, everyone. Welcome to Cassandra Lunch number 57. Don't worry, that'll be edited out of the YouTube video if Arpan's kind enough to do that for me. Welcome to Cassandra Lunch number 57. Today we actually have a guest speaker, Anil Mittana, and he's going to be going over using secondary indexes in Cassandra. His email is listed below, and I know he's also going to have his LinkedIn listed later in his presentation. Your organizers for this event are Raul, Arpan, and myself. We all kind of take turns doing this intro. Usually they don't have the same technical difficulties I just did, but I'm the newest member, so. We are always looking for more speakers and sponsors. So if that is something you're interested in doing, if you have a topic, anything related to Cassandra, definitely feel free to reach out to one of us at the emails listed below. As well as if you know of anyone who would want to sponsor an event like this, now that COVID's kind of winding down a little bit, maybe we can get back to hosting in-person events. I work remotely and live in Arizona, so I won't be able to join you, but hopefully I could tune in still and maybe lead the intro from the remote. We are a part of a larger community at Data Community DC, and Data Community DC, we do believe in diversity. So regardless of race, religion, any sort of creed, sexual orientation, everyone's accepted here, and we expect kind treatment to everyone. Some of the organizations involved with Data Community DC are listed here, and you can find out more at their blog, datacommunitydc.org/blog. They also actually would like to touch, they also have other events also listed down here at the bottom, events.datacommunitydc.org. So surrounding all things data. What we cover here is Cassandra and Cassandra related topics. So that could be anything from, well, Datastacks, the enterprise version of Cassandra, deploying Cassandra in Kubernetes or on Docker. We've covered a ton of different topics, and you'll see we do have a YouTube playlist, and I'll touch on that here in a little bit. But at this point, we do like anyone new to the webinar. If you're feeling confident, want to share your camera and your audio and say hi, tell us a little bit about what you do with Cassandra. This is your opportunity to speak up. Neil? Anil's our speaker today, so we can get his introduction later, but anyone else?
Hi, this is Sarma Paidpalli, and you see my nice icon there. I'm a gamer, and also I feel like that when I work on Cassandra. So you see the left data center 3 nodes, right data center 3 nodes. I live in Virginia. And I've been actively using Cassandra for like 7 years now. And I've been doing a lot of small contributions to the community, but yeah, I'm a contributor. Thank you.
Awesome, Sarma. Yeah, maybe we can get you to speak at one of these events.
Yes, I'm just writing email to you.
Awesome.
We'll work
Definitely reach out. We'd love to have you.
Thank you.
So some group rules. If you have a question, ask it. Be polite and courteous to others and share what you know. This is meant to be a discussion. Anil will have kind of his own set of rules, which he can address when he takes over. Some speakers tend to prefer questions in the chat to answer later in their presentation, or some are okay with unmuting and asking or contributing during. We'll just have to find that out from Anil and what he prefers. Here at Anant, we deal with big data in general, specifically using Cassandra, Spark, and Kafka is our wheelhouse. But all real-time data, big data, stream sets, that sort of thing, that's our specialty. And Datastacks is a partner with us as well, as I may have mentioned earlier. So they give us a lot of support, and we I know Rahul does a lot of work for them as well. GW University is also a sponsor. As I mentioned before, they have allowed us to use their facilities to host in-person meetups. And again, hopefully we can get back to that soon. Some of the other program sponsors, I mentioned Datastacks, Eastern Foundry. If you'd like to sponsor us, you could get featured here as well. And some organizational sponsors to Data Community DC are listed here. And 15-second announcements. So this is an opportunity for anyone who has jobs, meetups, hackathons, conferences, classes, anything they would like to share as far as events coming up that they're hosting and want to plug. You can use this. This is an opportunity to do so. No? All right. We will plug ourselves here. Anant is hiring. We are always looking for full-time or part-time data platform operators, engineers, or architects. You can find out more at careers.anant.us. And some of our upcoming events, Datastacks hosts weekly workshops. We also have a sister lunch to this, Data Engineers Lunch, which occurs every Monday at 12 Eastern time. So same time as this, just on Mondays. And there we cover a broader range of data engineering topics. Some upcoming topics we have, Rahul will be presenting next week. He's a really knowledgeable guy. He's kind of like a Cassandra encyclopedia, so you definitely won't want to miss that. As well as in the following weeks, we got functions, using functions in Cassandra. So those could be user-defined functions or some of the built-in Cassandra functions. And then after that, we'll be covering Apache Cassandra and Apache NiFi. And our events are listed at anant.us/events. All of these webinars are recorded, well, at least starting with the 10th edition of Cassandra Lunch. So if you check out Cassandra Lunch on YouTube, we have a full playlist covering a broad range of topics related to Cassandra. So definitely check out there if you feel like you want to learn more about Cassandra or a specific topic related to Cassandra. Chances are we've touched on it in some capacity, and it will be recorded on this playlist. Cassandra Link is also another great resource for anything you're curious about Cassandra. These are hand-curated links to different information about Cassandra. You can see in the tags there's Spark, Kafka, Datastacks, data modeling, and well over, I think this is kind of dated, but well over 1,000 links related just to Cassandra. So kind of like a one-stop resource. So definitely check that out if you ever have any questions about something related to Cassandra. And that is it for my presentation or my intro. Anil, we can go ahead and have you take over now.
Hey, thanks, Josh. Hey, Rahul and team, thanks for having me. I'm glad to be here. And yeah, hi everyone, whoever joined, thanks for your time. So today I would like to talk about secondary index. So one of the most misunderstood concepts of Cassandra, but I would like to give you a very clear explanation. I'll give you a very much in detail practical demonstration of secondary indexes. Now, what are the, let me share my screen. Yeah, so the idea is to understand secondary index in detail completely. So the agenda is, I'll start with, let's understand what is query first approach in Cassandra. Then slowly we'll understand Allo filtering. Then we'll start understanding secondary indexes, how Cassandra stores secondary indexes, what is the difference between distributed index and local index. And we'll also try to understand write path and read path of secondary index. And we'll see what are the best use cases for using secondary index and what is the worst anti-patterns. and we'll also try to understand what are the problems and limitations of secondary index, and we'll try to touch up one more type of secondary index, which is SASE. So we'll have a very in detail go through on this all the topics. So before we start, a little bit about me. I'm Anil Mittana. I'm a certified Cassandra admin and certified Cassandra developer. I love this technology, and you can find me on the LinkedIn link. And I also have a YouTube channel specifically for Cassandra DBAs. So that is the link available on the screen. So let's start with the topic. So let's understand what is query first approach in Cassandra. So we all know in Cassandra, you need to know your queries first. So even before you creating a table, you need to know exactly what is your application workflow, and you need to write down all your select queries. Then you can go ahead and create your tables, right? So that is how it goes. Now, let's say I want to get, okay, the client requirement is, so the client wants all the ratings left for a movie. So at any given point of time, a client will ask me, hey, Anil, can you give me all the ratings, all the rows, for a particular movie? So I just need to get that particular information from my table. So if that is what my requirement, what I do is I'll go ahead and create a table, something like this, or what you're seeing on the left side, right? So where I'll keep title as a partition key, and if you notice, email also there, part of my primary key, which you call it as a clustering column in Cassandra, which gives you uniqueness to your primary key, and also it gives you a clustering order within the partition, right? So the idea is, title, you have to keep title as a partition key if you want to look up by title, right? So that is what the requirement, and I created that table. So what we do is, like, we'll try to quickly see when you create a table like this and load it, load some data into it, the table looks something like this. So to demonstrate this particular scenario, I have a 3-node Cassandra cluster up and running on my AWS instance, and I'm using Mobile Extreme to connect to my nodes. So this is a very wonderful tool. I'll highly recommend if someone is practicing or learning Cassandra. This is a wonderful tool to connect to Cassandra clusters. So I have a 3-node cluster up and running. Quickly, I'll show you the status of my 3 nodes. Yeah, so 3 nodes are up and running.
Guys, can you please mute everybody else?
Okay, so our cluster is ready, and I have a table already created and loaded some data. So when you load data into it, the table looks like this. So if you see, there are 3 movies. There are 3 movies. Yeah, okay. So I have created this table, and there are you're seeing the data on that particular table. And if you notice how Cassandra stores the data, see, because you created a title as a partition key, which is your primary index, what Cassandra does is it will, because Cassandra is a distributed database, so your table is a collection of partitions, and each partition will belongs to one single node, right? So that is how Cassandra distributes the data. Now, all your avatar movie data will go and sit in one single partition, and that partition will sit in one single node. So the basic rule is the partition data will not be shared between the nodes. So let's say, like, tomorrow if Rahul watches a movie, Avatar, and he given rating 7, that data will come and sit inside this particular partition, and this partition will be in a single node. Now, if I want to query, let's say if I want to see what are all ratings we got for Avatar movie, what I do is I'll run a query something like this. So let's start from ratings by movie, where title is equal to avatar. Okay, so when I ran this, what happened is, I got this output from one single disk read, right? So you just get this information from one single node. So very quick. Now, let's go back to the slide. Now, let's say if after some time, maybe after 50 days or 100 days, a client came back and he asked me, hey, can you give me the rows for a particular user like Anil? So I want to see all the rows. Give me all the rows. What are all movies watched by a user Anil? Now, if you ask me that, I cannot give you that, right? See, because it's a query first approach. You have to have all your queries well ahead before creating a table. Now, if you come today and if you ask me, hey, can you give me movies watched by Anil? See, the answer is no, I cannot give you that. Let me get this output. Like, so if client came and asked you this particular thing, what happens is Cassandra will throw you an error because it doesn't distribute the data in that way, right? You can only look up by title. You cannot look up by email. I mean, you cannot look up by any non-primary columns, right? So you can only look up this particular data by using title in your where condition. Now, so these are some generic rules you have to understand before we going deeper into the secondary index concept. Now what I mean by allo filtering? Let's look back into our table and let me put all the rows one more time onto the screen. Let's say you have a requirement and I want to okay, let me pull the records. Give me the records where rating is equal to 8. So that is what your query. Let's run that query. So select start from that particular movie where rating is equal to 8. So obviously this query will not work, right? So it throws an error because the with the table design what we have, we can only look up by title. We cannot look up by any other columns, right? Now, but when you carefully look into that error, it is telling you something. Okay, see, you cannot execute this particular query because it might gives you an unpredictable performance. But if you still want to execute this particular query, use allo filtering. Let's say a developer read this message and he ignored everything and he just went and use that particular word allo filtering. Let's see what happens. So when you say allo filtering, now see we got the result. So the developer feels happy. Hey, initially this is not the way, but still it is allowing me to do this, right? See what just happened here is when you say allo filtering, let's say you have a 2 lakh records in that particular table and there are 100 rows which having rating 8. So what just happened is when you use allo filtering, so it will fetches all this 2 lakhs records and it will apply the filters on it and it will give you the output. So basically what you're doing is you are doing an entire table cluster scan. So allo filtering basically is not recommended, especially if you're on a production workload, because when you use allo filtering in terms of traditional RDBMS, you are doing a full table scan. Like if you talk about in terms of RDBMS, so in terms of Cassandra, what you're doing is you are bringing everything on into the into your node, then you are applying filters and you're getting that result. So so allo filtering, when you do this kind of activity, right, you are unnecessarily putting a lot of pressure onto your JVM heap, and there are chances you might bring down the node also if you use allo filtering. So strictly no to allo filtering. So then how can I avoid using allo filtering? So one way is create an index on rating column, right? So what I do, I'll go ahead and create index on a rating column. So I'm using the syntax create index if not exist on that particular table on that particular column name. So you don't need to provide a column name, you don't need to give an index name. It automatically creates with the same name as your column if you didn't provide index name. Now, so I have created an index on column rating. So now what I do, I'll run the same query. Now I'll remove this allo filtering now. Now let's run this, and we got the output, right? Now you might be asking me, like, if secondary index is working this way, right? Like, initially I just, like, few minutes back I told you cannot look up by rating, right? You can only look up by title. But now when you have a secondary index on any other columns, basically you can look up by rating, or you can look up by user location. All you need is, like, create an index on that particular column, right? Now, if this is working so well, then on the very first slide, why you asked me to create a duplicate table, right? What is the point of creating a duplicate table? Then I know when I wanted to look up by email, what I do is, like, I'll create a secondary index on email column. What is the point of creating a duplicate table in this case, right? Now, to understand that, we need to understand how secondary index will get stored inside Cassandra cluster, right? Now we know how to create a secondary index. This slide is telling how to create it. Now, what just happened when you create a secondary index? So what happens is, you have a table. This is what your original table, ratings by movie, and you created a secondary index on a rating column. So what happens inside is, Cassandra creates a hidden table with this structure. So you have a rating will become a partition key on the hidden table, and it will take all your primary key components into this particular primary key. See, so ratings will become your primary index in your hidden table, and it will take primary key of the original table into as a part of the primary key. Now, okay, good. So it is creating a one more table, hidden table with few columns, and it is maintaining. Now, what is the problem here? So what is the point of creating a duplicate table? So to demonstrate, what I do is, let's create a duplicate table also using a rating as a primary key, right? So what I'm telling is, here, what we do is, like, we have a secondary index anyway as of now. What I do is, I'll create one more duplicate table where I keep rating as a partition key, right? And I will load data also. So what I'm doing, I'm duplicating a table with rating as a primary column. So I'm going into that particular key space, and I'm creating that table. Done. So now we have a table ready, duplicate table. Now let's run where rating is equal to 8. Okay. So I ran a select query, and I'm telling, give me all the rows where rating is equal to 8. And this query, I ran it on a duplicate table, right? I got the result. Now, here, I ran the same query, but it is on the secondary index. By using a secondary index, I ran this query. Now, you have two things. One is you got the output from secondary index, and one is from actually a duplicate table. Now, what is the difference between these two? Now, let's focus on the duplicate table. Now, as we discussed earlier, so what happens when you have a rating as a partition key? Now what happens, see, every time some user gives rating 8, that data will be part of this particular partition, and this partition will be stored in one single node. So let's say all the ratings belongs to 8, all these rows will be in node 1. Now all ratings 7 rows are on a different node. All ratings with 9 are in a different node, right? So this will get distributed based on rating. So that is how your duplicate table stores the data. Now, when I ran this query on a duplicate table, select start from ratings by movie, give me all the rows where rating is equal to 8. When I ran it, what happens? It's a single discrete, isn't it? It will go and it will grab the rows from one single place. Super quick, right? So all good. Now let's understand what happened, what is happening with secondary index. What happens when you run same query? So to understand this, you have to really, so this is the core part of the whole concept. So, here a little more focus is needed. So we'll understand how Cassandra stores secondary index. Let's look into this. Now, if you notice here, right? So this is my original table, ratings by movie, okay? So where title is my partition key, and data is distributed based on partition key, right? Which is my primary index. Title is my primary index. Now I created a secondary index rating. Now what happens is, when you have a secondary index, that hidden table data, so when your index data will be co-located on the same node with the source data. So what I mean by that, now when you have a secondary index, see here, what happens here is, it will only stores the data, index data, which belongs to this particular records. See, now it has all the ratings given, 8 is given, right? Those records are there. So only like, three people given 8, 3 people given 7, 3 people given 8. Only that data on that node will be stored on this particular on that particular node. So your index data will co-located with the source data on the same node. Now, same thing happens on the second node, same thing happens on the third node. Now, you're running a query, right? Like what you're saying, select star from ratings by movie, where rating is equal to, you are saying 8. So to give you this output, what happens is, unlike your primary index, secondary index is not a distributed index. It will not use any Marmotri partitioner to distribute the data. Now, first thing, when you run this query, right, Cassandra cluster doesn't know where the data is basically. Now what happens is, it has to fetch every single node, and it will go here. Okay, give me, do you have rating 8? Yeah, I have. Okay, then what it does is, it will fetch the primary index, and it will go here, and it will get the records for you. So it happens on the every single node. It goes here, one index lookup, and it gets the primary index details, primary key details of the original table, and it will go there, and it will bring all the records from that particular table. So one lookup into index data, one lookup into table data, and this happens on each and every node. So what just happened here is, when you ran this particular query using a secondary index, basically every node will get involved in that particular activity. So, and moreover, not only every node will get involved, and there are two activities, right? One is like index lookup. One more thing is, your table lookup. Two things. So this is not scalable so obviously there is a lot of scanning is happening there. You might see timeout errors. You might see additional load on the coordinator node. So there are so much disturbance happens when you use a secondary index in this way, because that is how it is storing. Okay, you might be having a doubt. Now what is the point of storing in this way? Why can't it just distribute the way primary index is getting distributed? Why cannot it keeps all the ratings where 8 in one single node, all the ratings with 9 in one single node, all the ratings with 7 in one single node? Why it is not storing in that way? So focus here, right? Why it is not doing in that way? Because let's say you have 2 lakh records in your table, and 90% of the rows are having rating 8. So out of 2 lakhs, 95% of the people given, most of the people gives rating 8, right? So 90% of the rows having 8. No, if Cassandra stores the data in that way, what happens, if it stores, all the rating set in one single node, that node will become, that node will end up with wide partitions, isn't it? That one single node has to keep 90% of the index data. So that is one reason. And one more reason is, if you store local, if you store your index data locally, you can easily update whenever you want to update your index data. You can easily update, if you store it locally. But if you distribute it, it is very tough to update your index. That is the problem with the materialized views, isn't it? So to avoid those two conditions, Cassandra, what it does is it will keep your index data on the same node with the source data. So let's quickly go through the slides also once. Now, what are the technical reasons? That is that is what we just discussed, right? Why it is not storing index data along with the original data, right? So to reduce the index update latency, that is what we discussed. So if you have index data locally, you can easily update, and obviously, avoid arbitrary wide partitions, right? We just discussed, if everyone is giving rating 8, you will end up with wide partitions. Two things, right? Now, distributed index and local index. Obviously, distributed index is what is your table primary index and materialized index, materialized views. These are the examples for distributed index. So that is what we discussed, right? When you have a distributed index, when you run a select query, all you need is getting it from one single disk. When you have a local index, it will not scale well, because that is what happening with your secondary indexes, right? Secondary indexes uses the local index concept. Now if you have a partition key, a primary index, right? See what happens in, you have a 100 node cluster with replication factor 5. All is happens there is like, it will involves 5 nodes with the coordinator, like mostly 6 nodes will be involved in that particular query. But if you have a local index and you're querying it, right? Like you have a 100 node cluster, you have to hit every single node to get the result back, when you're using a secondary index. Now let's also understand, write path and read path of the secondary index. This is also very important, because see, when you have a secondary index, when you have a hidden table, what happens is, index mem table and base mem table will basically, flushed into SS table at the same time. But obviously there is no guarantee again. And your index, secondary index doesn't have any physical representation. It is a hidden table which Cassandra manages automatically. So basically, so you cannot even have a physical representation of it, right? Now, one more thing to point here, right? Once the data got flushed, index data and actual data get flushed into your SS tables, both this index data and your table data will follow a different life cycle for compactions and repairs and all that stuff. Okay, so that is what happens with the write path. Read path we just witnessed. Every time when you read, whenever you want set give me ratings is equal to 8, we just noticed it, right? What is happening there. So it will go and look into each and every node, index lookup, get the primary key, and go and look into the actual table and get the results back. Now that is what happens with the read path. Now if secondary index is like not scalable, then what is the point of having them inside Cassandra, right? So obviously there should be some reason why they have secondary index. Now secondary index, one thumb rule to notice here. See, if you are in a RDBMS world, traditional RDBMS world, creating a secondary index is very common practice. Whenever there is a query performance issues, you will tend to create indexes. But in Cassandra world, creating index comes with a cost. We just witnessed it, right? What is happening? So lots of nodes are involving to give you the output when you use a secondary index. Now, when can I use them? If secondary index is having a lot of trouble, what is the point of having them? When can I use it? So obviously, the very good practice to use a secondary index is always involve. Let me put this thing one more time. So select start from this particular table. So this is what you're querying, right? Now, the very good practice is always include your primary index along with the secondary index. So what I mean is like, I'm asking put title is equal to avatar. Okay, so if you ask till here, this is a very expensive query, right? So this till here, till this portion, this is an expensive query because every node will get involved in it. Now, what would be a better way of using secondary index? Always include your primary index along with the secondary index. Now, what I'm asking, give me ratings, give me rating 8 for a avatar movie. So give me all the rows where rating is equal to 8 for a title avatar, or for a title Lucy, or title Interstellar, right? So expensive query. Give me all the rows where rating is equal to 8. Expensive, not suggested. What would be a better query? Give me rows where rating is equal to 8 for a particular movie. So that would be much more better query, because when you run this particular query, right? Let me put that here now. So what you're doing here, you're limiting the number of nodes, isn't it? You're only querying it from one single node. So this query, even though you have 100 nodes, this query will go and hit only this particular node, only one single node. It will go here and it will get the records from one single disk, one single read. So this would be a better way of using secondary index. And what else you can do? You can even ask, so, this particular query, you got it from one single disk read because you are putting primary index on it. Now, one more better way to use secondary index, limit it by using a limit. Let's say, if you say limit, like you are asking only give me 3 records, right? So you are limiting the output so that, it doesn't need to hit every single node to give you this particular output. So Cassandra will internally uses some kind of algorithm. So instead of touching every single node, it will try to give you that output as, with hitting less number of nodes. So the idea is, when you are using a secondary index, the basic idea you have to remember is try to narrow down the number of nodes you query, right? So you have to hit less number of the nodes to get the records back. So one way is, include your primary index along with the secondary index and use limit. This would be some good use cases when you using a secondary index. And obviously secondary indexes are very, very helpful when you are using analytics workload, especially, in Spark jobs. Now, what are the anti-patterns? So this is very important. Now, you should never create a secondary index on a column with a very low cardinality. For example, gender. So there are only 2 options. It is very low cardinality. Now, what happens when you create it, right? You will end up with wide partitions in every single node, right? And obviously, you shouldn't create, secondary index on a very high cardinality index. For example, gender. Oh no, email would be one example. So email is like, there will be lots of distinct values, right? So if you create a secondary index on a email column, so to give you, like, when you query, right, you might get the output by querying one single node, or you will end up querying every single node, and you might get a 0 results. So both are, you have to avoid both the conditions, very low cardinality and very high cardinality indexes. And obviously you have to avoid indexing on a column which is like, if you're frequently updating, always try to not create index on it. Now, what are the additional problems? Right now we saw some kind of problems, and there are some limitations again on when you use a secondary index. One is like, you cannot run range queries. You cannot use like operators on your secondary index. That is a limitation. And obviously maintaining indexes through hidden tables is again, it's a tough, because your table data is compacting in a different life cycle, and your index data going in a different life cycle. So there will be some kind of a disturbance happens if your table data will get compacted very much quicker. So there are limitations, and there are like good ways to use, and you have to understand all these things, consider all these things when you're using secondary index. Now there is one more secondary index type Cassandra is giving, which is SASE index, storage attached secondary index. When you use this particular index on your columns, basically it will allow you to run range queries, and you can use like operators and all on your select query. So we'll quickly look into that area also once. Now what I'm doing is I'm creating SASE index on user location. So let's do that. So we have created SASE index on user location. Now, what is expensive analytics query, right? So this is what, if you, so first thing first, you are allowed to use like parameters and all, right? See, give me rows where user location like, starting with you, right? So I'm getting it. But again, remember, everything is same in the background. It has to go and grab it from every single node. What would be a much better way of querying it? Always include your primary index also. So that way you can reduce the number of nodes involved in that particular query. So SASE indexes are good. What I'm doing is like, I'll quickly flush data. What happens is when you have a SASE index, it creates one more, SS table for you for index data. So let's quickly look into that. Yeah. So when you use Cassandra, it creates all these folders for you. So here is my table folder. And if you notice, a SASE will have SS table. So it doesn't follow the tables original compaction process or life cycle, right? All that stuff. It will follow its own compaction process, its own repairs and all that stuff. So that is the reason it puts you additional pressure for you. Compactions again. Your index data will have a compactions. It will be participated in your repair. So all these things, this is the reason you have to consider very much carefully whether to use them or not. And anyway, SASE indexes are not recommended for production, and they are not production ready. If you notice, when we ran, actually we got that message. When we created a SASE index, it gives you a warning. It is not production ready. So because there is a overhead and there is a development going on, and we'll see if we get any better advancements on using secondary index if it gets production ready. So as of now, secondary indexes, when you have a SASE index, you will have a separate SS tables, and they will be involved in compactions and repairs. So you have to be careful when you use them. Now, final thoughts. Obviously, secondary indexes will not give you performance, but they are very much convenient. They are there to give you convenience, not performance. Okay, so you have to really understand, how this works, and so these are the some use cases. We already discussed. Include primary index along with the secondary index when you're querying, and obviously do not use any very high cardinality or very low cardinality columns. Do not create your secondary indexes on them. And the general recommendation is to have at most one secondary index per table, and in a very good way, you don't even need. So try to duplicate data, because Cassandra encourages you to duplicate data. So if your query requirements are that strong, then instead of creating a secondary index, always it is good practice to have a one more duplicate table, and there are ways you can integrate this table data in both duplicate table and original table data. So that's it. I'm almost reached the end. So if you have any queries, I would like to answer them.
Thank you, Anil.
Yeah, I had a question. So obviously if you have a secondary index and you're doing a query, it's going to go to all the nodes. So correct. I don't know if you mentioned, but basically I think the recommendation when you're using secondary index is that if you can help it, if you have at least the primary key, it can help with a query. Otherwise, it's still going to do it'll do a cluster scan, but it won't be a full table scan.
Yeah.
Right. Okay.
Yes. Correct.
Right. So it's not a trick question. So why is there allow filtering, right? I know what the answer is, but what is just for the group? Like, what's the reason for having allow filtering if you're not supposed to use it?
Yeah. See, allow filtering is still good. If the table is very small. But yeah, I would like to listen from you why it is there, if it is not so much recommended to use it.
Well, again, it's the same thing, right? If you have the partition key and you have clustering columns, then you want to do a query on a clustering column that isn't that it's not a clustering column, excuse me, or you want to do it in the order that's different from how the clustering columns have been ordered in the primary key. So if you have the partition key, you can do an allow filtering on that partition, and actually you can get what you want, and it's not expensive as you would imagine because it gets the partition. Regardless if you read one row or the whole partition, Cassandra is going to bring up that partition into memory. So if you do allow filtering on one partition with many rows, it's fine. That's the perfect use case for that.
Good.
Yeah, the other use case is when you're using Spark, you kind of have to do allow filtering with token ranges to get the data. Otherwise, Spark cannot get everything. So it has to do with filtration using token ranges. But those are pretty much the only reasons why I think you can use it. Otherwise, it's a bad use case, like you said.
Yeah, perfect. Good to know those 2 points.
Yeah, because people always ask, it's like, if you're not supposed to use it, why is it there?
Yeah.
Cool.
I have one question. So this mostly for Rahul. Basically, it's on the same allow filtering within one partition, right? Mm-hmm. So Rahul, as you mentioned, when we have the partition key in the filter where clause, so obviously it is reading only one partition, and then you have your custom order by allow filtering and all that. So the question for me, I don't know, I don't understand the mem table in that case is it going to store your custom ordered data in the mem table before giving it to you, or it just gives you the output and during giving you that output, it just orders it as you want?
Yeah, so in the mem table, the partition is represented in the mem table. So there's a difference between mem table and, let's say, what's called the row cache and the key cache, right? When you do a query and you get something back, if you have the same exact query and if the row cache happens to have that data, it will give it to you. But technically, the mem table and the SS table, the partition rather, is kept intact. This is why, for example, when you're writing data, right, it goes to the mem table and it goes to the commit log simultaneously. This is the reason why when you ask for that data, all of the data for that partition is generally available in the mem table for you to be able to access. And if it isn't, it gets it and it keeps it up to date for that particular query. Over time, if you're not using it, it gets flushed out when you do mem table flushes. But that's my understanding, is that mem table is supposed to be a representation of the partition in memory, whereas SS table is a representation of the partition mutations on disk, such that over time they get compacted into more and more efficient representations of the same partition.
That makes sense. So the follow-up on Spark side of it, when we are running a Spark query with, let's say, you don't have the partition key in there for filtering. So as you mentioned, it internally uses the token ranges to filter, right?
That's right.
Okay. So we don't have to do further with Spark itself. We don't have to write Allo filtering. Basically, it knows how to do that optimization.
Yeah, what Spark does is, if possible, it uses the mechanism that is there on the native data source. So what I mean by that is Spark can work with any data source, right? So if it works with Cassandra, it tries to push the predicate down to Cassandra. If it can handle it via CQL, it does it. Otherwise, it has to gather all the data and do the filtration. And the way that it gathers it is, if you have multiple nodes, it will break apart the query for the multiple nodes, and that's where it does those token range queries. But if you have a secondary index, if you have a SASE, or if you have a Solar index, it is possible to basically push that predicate such that it doesn't necessarily do a table scan, right? It will just push the query down to CQL. So if you actually use an index, Spark can use the index. It doesn't have to do a full query every time.
So for future, Rahul, I have one request on that push down predicates with Spark to CQL. Mm-hmm. With a lot of research, I'm unable to find any material on it. So okay. It will be a wonderful topic to talk, because even though I made a 4-hour course, I have no clue how to do this predicates, push down predicates. Thank you.
Sure. Yeah, I remember when I had to figure it out before. There was nothing out there. Okay, I have made a note for myself, and I will see if I have any material from my previous work that I can kind of, that I can leverage. Otherwise, we'll just have to put it in the backlog and try to get to it as soon as we can. Okay. Excellent. Thank you. It was a good question, Sarma.
And thank you, Anil, for presenting this. This was a wonderful topic. We keep telling everybody don't create indexes, but we don't go further telling them how to create those indexes, if at all it has to be created. Without taking too much time, Rahul, somebody at Datastacks told me that you can actually customize that Allo filtering message, saying, if at all you use this, you will be fired from the company. Funny message, but it is important. So I have not figured out how to set the custom message unless we go and tweak the original code and recompile it. But if you know any other method, let me know.
I offhand, I don't know, but that's, I think the code is the surefire way of doing it. I do know, related to this, I do know that at least in the newer versions of Cassandra, and definitely in Datastacks, there are kind of different, I know in Datastacks, I have to double check in Cassandra 4, but there are guardrails in which literally it doesn't, you can turn it on and it won't allow people to do it, basically, right? It just turns the feature off. Otherwise, what will happen is, if it's a business critical, health critical, mission critical system, not that somebody's intending to do damage, it's just, it's a lack of knowledge sometimes. Or what happens is that they're connecting to it via some, GUI tool like dbeaver or Tableau. And instead of using Spark SQL, if they're connecting to it via the JDBC CQL, right? Those type of queries will bring down the cluster, right? So, and they don't even know that they're doing it. The tool is generating that query. And so that's why it ends up happening that way. But yeah, that's a funny thing, but it's true. I think this is the reason why, when we recommend, putting reporting tools in front of Cassandra, we say, separate that data center completely, right? Put that in a separate data center. Those queries should go to a separate data center, not to the primary data center. Otherwise, somebody will get fired. Don't do that. So good. Thanks for bringing that up. Yeah, thanks again, Anil, for great in-depth presentation. Very important for everybody to understand how to use secondary indices. I think the SASE indexes are very powerful, but as you mentioned, they're not recommended for production.
Yeah.
The storage attached index, which is been open source, I think eventually will make it into the Cassandra code base. That's like the better version of both. That's really the future, I think. But for now, secondary index and materialized views are kind of our way of doing things.
Yeah. Yeah.
Great.
Hey, thanks everyone for joining.
All right, guys. We'll see you next week. Same time, same place. Have a wonderful week. Take care. Thanks, Josh, for starting us off.
Thanks, Anil. Later, guys.
Thanks, everyone.